Welcome back, everyone. We are continuing our section 7.2 on arithmetic sequences and series. Today we're talking about arithmetic series. An arithmetic series is another name for the sum of the terms in an arithmetic sequence. So if I have a list of numbers like 1, 2, 3, 4, 5, 6, and so on, I can find the sum of the first 4 terms, or the first 6 terms, or the first 8 terms, or the first 90 terms of this sequence. There are 2 formulas that we can use for this. Our first formula we use only if you know or can find out the first and the last terms. Again, n, all 3 of these n's should have the same value, and n is the term number that you're trying to find the sum of, like 12 terms or 15 terms or 5,097 terms. And then the only other thing we have to know in this formula is a sub 1, which still stands for the first term. So if I were using this formula, I would say to find the sum of the first 12 terms, then I would have 12 over 2 times the first term plus that 12th term. And I would have to fill in those 2 values, and then I could do the math and find out the answer. The second formula that we have is, I don't know the first and the last term, but I do know the first term, and I know the common difference. So again, all of these n's are still standing for term number. A sub 1 is still the first term. And this time, D is our common difference. Example 7 in your notes. So we have this sequence, -9, -5, -1, 3, and 7. So what do we know from this? Well, we know that 9 is our first term. And we know that our common difference, or the rule that we're using to get from -9 to -5 to -1, to 3 to 7, is by adding 4. So our D is +4. It's asking us to find the sum of the first 12 terms. So I could go and take this sequence. We have 5 terms right now. I could keep adding 4 and get a list of the first 12 numbers, and then add them up and write the answer. Or we can use that second formula, because I don't know right now what the 12th number is. I could find it, which would be just using an equation to use an equation. Or I can use that second equation where we say S sub 12, n is 12. We have 2 times our first term is -9 plus n is 12 minus 1, and our D is 4. 12 over 2 gives us 6 times -18 plus 12 minus 1 is 11, and 11 times 4 is 44. So I do all of that math there, And I end up finding that the sum of the first 12 terms, so if I add all of the first 12 numbers together, I would get an answer of 156. For letter B, evaluate the sum of the first 60 positive integers. Well, the first 60 positive integers are 1, 2, 3, 4, 5, and so on until you get to the number 60. That means that we know our first term and our last term. So we can use that first formula. Sum of the first 60 terms. We have 60 terms. Our first term is 1, and our last term is 60. 60 divided by 2 is 30. 30 times 61 will give us 1,830. So if I added all of the numbers from 1 to 60, I would get 1,830 for that. Let's take a look at the second set of numbers. For our second set of numbers, our first term, our a sub 1, is 48. And then our rule, or our common difference as we're moving along, is to subtract 4. So our d is -4. So they want first the sum of the first 21 terms. So again, I could subtract 4 and continue on and find 21 numbers and then add them all together, or I can plug them into one of my sum formulas. Again, we don't know what the 21st term is, so we would have to use that second equation. S of 21, 21 over 2, 2 times that first term, plus our n is 21 minus 1 times -4 for our d. So I'm going to do all of this math in that calculator and find out that the sum of my first 21 terms is 168. Now you might say that doesn't make a whole lot of sense because we're adding 21 numbers together, but remember, the numbers are getting smaller and smaller and smaller as we go because we're subtracting 4 instead of adding 4. For part B, the sum of the first 200 positive integers. So that means 1, 2, 3, 4, 5, all the way till 200. Integers are just numbers, and they're positive, meaning we don't want to use -1, -2, -3, -4, -5. We know then that our first term is 1, and our last term is 200. We also know that we have 200 terms. So we can use that very first formula. The sum of the first 200 positive integers is 200 over 2 times 1 plus 200. 1 is our first term, 200 is our 200th term. That's 100 times 201, which makes the sum of that first 200 terms of positive integers 20,100. This is where we're going to stop for today. Have a good one.